Okay, this is going to be kind of a challenging thing. It's applications you haven't seen before, and all the problems are different, okay? It's challenging, okay? If you have a question, you got to let me know after I'm done with doing my thing today in front of the class, and you can ask. Now, all these are in relation to shapes, okay? It's going to help you in geometry and in advanced algebra trig. And in this class, if I decide to start doing some algebra, some geometry, okay? Now, it says, suppose you want to put a frame around a painting that's 24 inches by 16 inches. The frame will be the same around the entire painting. Now, you have 276 square inches of, you need to put framing material. So that's not for that square inches is not the area of the whole thing, it's just the frame that I have available, okay? How wide should the entire frame be? And that's key. So I have to find the width, okay, that's my answer. And they're talking area of a rectangle, so we all know the area of a rectangle is length times width equals area. Well, first we know the area, okay? And you're like, well, how? Well, we know our framing material is 276, and then we add the area of the picture, which is 24 by 16. And that's going to be 384. So we got to combine those and add them together, and that's going to be the area that I'm able to fill. That's 660, so A is 660. Now, as far as the length and width go, we're going to replace those with parentheses. And we're going to draw this little picture, okay, of a picture and a frame. We know the picture is 24 by 16, and we know the frame is the outside. So they're talking length of the whole thing, because remember, the 660 square feet would be the area of not only the picture, but the frame along with it. So I measure the bottom, okay, and from here to here is 24. Then you got x, x. Okay, so the length is expressed as 2x plus 24, or 24 plus 2x. Okay, then here you got 16 and then x and x, so that's going to be expressed as 2x plus 16. Now I just need to solve the equation for x. First I use the FOIL method. 2x times 2x, 2x times 16, 24 times 2x, and 24 times 16, okay? So that's 4x to the second, that's 32x, that's 48x, and that's going to be 384, okay, right there. Okay, so I combine the like terms, that makes 80x, so we have 4x to the second plus 80x plus 384, and then it's equal to 660. Now I just have to worry about finding the two answers for x. But you got the second power, but you got x along with it, so you're going to have to move everything to one side and set up your factoring procedure. So I want a 0 here, so I subtract 660. Okay, and that's going to be 4x squared plus 80x. Then 384 minus 660 is going to be negative 276. Okay, so there's three terms, so we go GCF T. GCF negative, no. Let's see if you can divide those by 4 first. So see if 80 divided by 4 is 20. 276 divided by 4 is 69. So 4 will work. Okay, so I divide all these by 4. And that leaves me with x to the second plus 20x minus 69. Okay, so I go put a 1, A, B, C. So A times C is negative 69. And I know last year I said, okay, if it's negative, you're going to minus to 20. What I've been telling the Algebra 2 folks this year is if you have a negative up there, go positive, negative, because you need a positive times a negative. And I always have them add to 20 positive, okay? So 1 in 69 is not even close to adding to 20. It doesn't add to 20 in any way. 69 divided by 2 is a decimal. 69 divided by 3 is 23, okay? Now again, positive, negative, and I think that adds to negative 20. But if I have positive 20, all I need to do is make that a plus and that a negative. Just swap the signs, okay? And that's how Mr. Larson explains factoring, so you might want to kind of switch your method. Always try to add, and then if it doesn't work with the signs, if you have the wrong sign on the number, just switch them. By the way, if that's a positive, it's either negative times negative, positive times positive. Okay, A is 1. If A is 1, then we can go with just x minus 3 times x plus 23. Now our GCF 4 is there, but I don't really need it to solve the equation because it doesn't have x. These are the two factors. So x minus 3 equals 0, x plus 23 equals 0. So if I add 3, I get 3. Subtract 23, you get negative 23. So 3 is your final answer. Now, word to the wise on problem number 1, okay? You know how on this problem, I took that times that and then added the 276 to it. You won't have to do that on problem number 1. You're going to have your A right away. Your A is just 864, okay? You just use 864 right away for your A. And then do your 2x plus 20 times 2x plus 25 and solve it. Now, these are different, as I said, okay? Some of them are new, like this one. You haven't seen this one done before. I think we did some of that first one in Algebra 1 or something like it, but then the next 3, no. Okay, a rectangular swimming pool is 6 feet deep. One side of the pool is 2.5 times longer than the other. The amount of water needed to fill the swimming pool is 2,160 cubic feet. Find the dimensions of the pool. Okay, you're finding the dimensions, so we need 3 of them because when they're talking cubic feet, there's 3 dimensions. And that means they're also talking about volume. Okay, length times width times height equals volume. And our volume's given to us in the form of 2,160. I'm going to make a parenthesis for the length, the width, and the height. Now, you actually have your height right away because the depth is the height. So you can go ahead and put a 6 there, and you also have your answer, the third one. Now, the length and width, you have to use that one side of the pool is 2.5 times longer than the other. So we're going to have x be one of them. Doesn't matter which one. And the other one we're going to have as 2.5x. It's not x plus 2.5 because 2.5 times insinuates multiplication. Okay, so you just put that in there. And you don't need to draw any distributions, okay? Because you only do distribution when you have addition or subtraction operators within the parentheses. We don't have that. We're just going to take 2.5 times 6, which is 15, and x would be x to the second equals 2,160. At least I think 2 point. And now I'm going to divide. I don't need to factor. I just divide by 15. And then I'll find the square root of this quotient here. So 2160 divided by 15 is 144. And then we are going to be finding the square root of 144, which is 12. Okay? Don't put the negative 12 because this is a story problem. Okay, so one of the dimensions is 12. Now, if you know x equals 12, to find the other dimension, you can just take your 2.5 and multiply it by 12. Okay? And that is going to be 30. Now, to check your answer, you can multiply all 3 of them together and see if they equal 2,160. Yep. So that one didn't take a long time, mainly because I didn't have to factor. Okay, now there's a different one. The town is planning a playground. It wants to fence in a rectangular space using an existing wall. What's the maximum area it can fence in using 100 foot of fencing? So you're finding the maximum area. So we know what we do on maximum problems, okay? We make our parabola. We're finding the coordinate point for x and y, and then opposite of b, divided by 2 times a. And then y is found by replacing x, okay? Okay, now you're talking area, that's true, okay? So area equals length times width, okay? Or I've been putting equals a, you can do that, that's fine, okay? Okay, now here's what the picture looks like now. you're going to draw this little thing here, an imaginary line that says wall. Obviously, we're not going to put a fence on that side. That's enclosed by the wall. Now, the fence goes here, here, and here, okay? Because right now you're probably thinking, how the heck do I get the length and width out of that, okay? Well, there's a way to do it, okay? Remember, you don't need the wall. So here's what you're going to do. These two parallel sides we have to build fence, we're going to call those x's, okay? So the length I'm going to call is just x. Now the width can be expressed in terms of x. Remember, you got 100 feet of fence, okay? But you're going to use x feet there and x feet there. So that the remaining amount is 100 minus 2x, because you're subtracting 2x's. Okay, and that's how we're going to express our width, 100 minus 2x. Okay. Now let's multiply that out. By the way, we don't replace the a on a maximum, okay, because that's your job to find the maximum area. Because you know, like on revenue, you always got a y and an x. Well, here, the a is going to turn into the y, okay. All right, so multiply that out. You just FOIL it, okay. Well, not FOIL, just a distribution. X times 100 and then x times negative 2x. So you're going to have 100x and then negative 2x to the second power. Now, so we want to put the negative 2x to the second power first, and then the plus 100x, and then equals y. Now we have our a and we have our b. So the opposite of b is negative 100, and then you got 2 times negative 2, that's negative 4, and then divide, you get 25. Okay, now to find your y, which is the maximum area, you replace your x's with 25. So I go negative 2 times 25 to the second, plus 100 times 25. And then you got 1,250, and that you can put that there. That's your maximum area. So again, it's like length times width equals area. The area turns into y. Okay. Then remember, we don't need fence on this wall right here. So I call the two sides I have parallel x, because that's the length. And the width is 100 minus 2x, because I have 100 feet, but then I'm using x feet there and x feet there already, which means I'm subtracting 2x from there. And that can be that. Then you multiply it out, you got your a and b. Okay, my last problem. The area of a rectangle is 36 square inches. The perimeter of a rectangle is 36 inches. What are the dimensions of the rectangle? So it's a rectangle, so there's only two. Okay. Put length and width right there. Okay, now they're actually going to be a system of equations here that we're going to use. Okay, because they give me area and perimeter. Now area, we all know that's length times width equals area. And in the meantime, the perimeter is adding the sides. So you're taking two lengths and adding two widths, and that's your perimeter. That's kind of the way they write perimeter. Okay, so we know the area and perimeter already. They're both 36. I think in the problem you're going to do, they're not the same, which is fine. Okay. So length L times W equals 36. And then 2L plus 2W equals 36. Now, what we need to do in this equation, okay, you can't do the times. That's not going to work, and the reason why is because I see a multiplication here, and that throws that out, okay? If that said plus, I'd be able to use it, but it doesn't. So what you need to do is go into your perimeter equation and isolate the L variable, and that's easy to do. You just subtract 2W and then put it behind 36, and then divide by 2, okay? And that'll give me L, everything by 2. So L equals 18 minus 1W, okay? So again, you got your length, width, and perimeter. You're going to need to isolate the L variable. You could have done the W too. It doesn't really matter, okay, on your perimeter equation, simply by moving the other one over, by minusing it, and dividing by the 2 coefficient. Now I'm going to use the substitution method here. I'm going to box up the L and circle the other side. And I'm going to write the other equation. L times W equals 36. Okay? So L is the variable that needs to be replaced with 18 minus 1W. Okay? Now multiply that out. You distribute. Okay? So you're going to be taking 18 times W, and then you're going to be taking negative 1W times W. So that's 18W, that's negative 1W squared, okay? So you write negative 1W squared plus 18W, and then and then equals 36, okay? Now we have to get the equation equal to 0. We do. Okay. So I minus 36, so negative 1W squared plus 18W minus 36 equals 0. Now there's 3 terms, so we go with the GCF and the T-chart. GCF, you're actually going to do negative 1. Okay. 1's a GCF, but it's a negative in front. So that switches everything to its opposite. So we have W to the second minus 18W plus 36. Okay, ABC. 1 times 36 is 36 positive, so the signs now have to be the same. They could both be negative. I usually start with them both as negative, and then if I have to switch it to both to positive, I will. Okay, and I'm adding to try to get to negative 18. You got a little problem there. 1 and 36, no. Negative 2, negative 18, no, that's negative 20. And then if I divide by 3, negative 12, that's negative 15. I have crossed the 18 threshold, which means I have to use my quadratic formula. So opposite of B, plus or minus the square root, B squared minus 4A and C over 2A. Okay, so the opposite of B is 18. B to the second, it's going to be negative 18 to the second. And then 4A, A is 1, C is 36, then A is 1. And we know 2 times 1 is 2. So we're going to calculate that square root. Minus 4, 1. Okay, 13, rounded nearest 100, 13.42, and now I can get my 2 answers, okay? So 18 plus 13.42 equals, divide by 2, so I got 15.71. And the other one's probably going to be a negative, we'll see, okay? No, I don't think it is. 18 minus 13.42. Divide by 2, and that's going to be 2.29. I would use the higher one. That's just what I would do. Okay, to be honest with you, I would use the higher one. So 15.71, and that's your W. Now to get your L, it's actually pretty easy, okay? Remember, you know your length times width. Look at the area. You know your length times width is 36. Well, if I know W is 15.71, I can then just divide 36 by 15.71, and that's going to be about 2.29, okay? Now, if you want to check your answer, you can multiply them 2.29 times 15.71, and that's about 36. Remember, you have to do some rounding. And then you can substitute 2. And then L is 2.29 plus 2, and then the W is 15.71. And that's 36 dead on, okay? Again, if you get 2 answers, pick your larger one. So again, you start off with these 2, you isolate there, and then you replace whatever letter you isolated with that expression. And then you multiply out, it becomes a quadratic equation where you would factor it. And if the factoring doesn't work, you use quadratic formula.